Okay, so today's lesson is two parts. We're looking at percent conditions, and then we're going to look at properties of rational numbers. So we'll start by looking at percent conditions. So basically, when you're given a portion of a whole amount, you may be asked to determine what percentage this is of the whole amount. You can also find out what the whole amount was if you are told the percentage of the whole amount that you have. So for example, if you were told 42% of 86 is X, and we need to solve for X. So there's a couple ways you can do this. So first of all, 42%, we know that's 42 out of 100. Right? If we put that into fraction form, and then we're just multiplying that by 86. All right, anytime you see a dot like that, it does represent multiplication, and then we know it's equal to X. So here now you can just multiply, or you can just change that to your decimal and multiply using your calculator. You can do that as well. So 0.42 times 86 will give you your answer of X. Okay, so once you put that into your calculator, I'm just going to grab my calculator. So 0.42 multiplied by 86, that gives me that X is equal to 36.12. So the next example, we are told 54 is X percent of 72. So we still need to figure out what that X is. So reading this correctly, 54 is, so 54 is, meaning 54 is equal to X percent of 72. So X over 100 multiplied by 72. Again, that dot represents multiplication. Okay, so now we can just multiply this out. So 54 is equal to, so 72 times X, which gives me 72X over 100. All right, we're still trying to figure out X. So here I would use cross multiplication to figure out X. So I'm just going to put this over 1. So we'll multiply these two numbers together. So I'm going to multiply the 54 multiplied by 100, which gives me 5400 is equal to 72X. Okay, and then lastly, we're still trying to solve for X, so to divide by 72 on both sides. All right, so 72 divided by 72, that will just give me X. And then 5400 divided by 72, just putting that in my calculator, which gives me 75. So therefore, it's 75%. Okay, so 54 is X percent of 72. It's 75%. All right, so for these two examples here, the first one, we're trying to solve 30% of 65. So anytime we see the of, we know that means multiplication. So up here, I just showed that 30% in decimal form is 0.3, or you can do 30 over 100. And then it's being multiplied by 65 to give us X. Okay, so 0.3 times 65, or you can do 30 divided by 100 times 65, and just put that in your calculator, and you should get your answer of 19.5. All right, so we would say X is equal to 19.5. Okay, for the second example, we have 190%. So putting 190% into decimal form, you can just move your decimal point 2 to the left. So 1, 2, your decimal point is there. So 1.9, sorry, that's a decimal point. All right, and we know 190% of X. So 1.9 times x is equal to 240, and we have to solve for x. So you do have to use your algebra skills a little bit here. Now we're going to divide by 1.9 on both sides, which leaves us with x is equal to 126 point, I'm just going to leave it at 0.3. All right, so next we are looking at properties of rational numbers. This is in your modules under 1.7, and you have this chart under 1.7. So if you need to refer back to it, you can do so right in your modules. So the first one is commutative property. So if we look at addition, the addition example, so if we have 12 plus 2, it's equal to 2 plus 12. So it works for addition. For subtraction, it does not work. 9 minus 5 is not equal to 5 minus 9. Okay, it works for multiplication. 5 times 9 is equal to 9 times 5. Both sides will be equal to 45. So it does work for multiplication, but it does not work for division. Okay, so the order does matter for commutative property. It doesn't work for subtraction. It does not work for division. Okay, so for division, 20 divided by 5 is not the same thing as 5 divided by 20. The next one is associative property. So here we have brackets. It still works for addition. 8 plus 5 in brackets plus 3 is still equal to 8 plus 5 plus 3 in brackets. It still works for addition. Does not work for subtraction. In this example, we have 9 minus 7 minus 4. It's not the same thing as if we put 7 minus 4 in brackets. 9 minus bracket 7 minus 4, they're not the same thing. And notice it's the equal sign with the slash through it. That means it does not equal to. All right, associative property will work for multiplication. So multiplication, it doesn't matter what order you multiply. So the brackets they don't matter when everything is being multiplied together. 5 times 3 in brackets times 2 will still be equal to 5 times 3 times 2 in the brackets. But again, it will not work for division. Next is identity element. So here, if 0 is the identity element, 0 plus 13, it's equal to 13. Subtraction, when you subtract by 0, so 7 minus 0 in this case, your answer is 7. When we multiply, anytime you multiply by 1, your answer is, in this example, if it was 19 times 1, your answer is 19. If it was 10 times 1, your answer is 10, and so on. Same thing with division. If you're dividing by 1, your answer is still the first number there. So 25 divided by 1, so the answer is still 25. Note that anytime you divide by 0, it's undefined. All right, so any number divided by 0 is impossible, and you would just write there undefined. Zero property, anytime you multiply by 0, the answer is always 0. And then additive inverse, so that just means if you have, for example, a positive 6 and you're adding it to the negative 6, you'll always end up with 0. So the positive number plus its negative, you'll end up with 0. So negative 12 plus positive 12, the answer is 0. The next one is multiplicative inverse, or taking the reciprocal. So if you take the reciprocal and multiply them together, you'll end up with 1. So for example, 3 over 5, its reciprocal is 5 over 3. If you take 3 over 5 times 5 over 3, you'll end up with 1. So there's a couple more examples shown here. We have negative 3 over 7 times its inverse or its reciprocal, which is negative 7 over 3, and you'll end up with the answer of 1. The next one, you have 15. Its reciprocal will be 1 over 15. If you multiply 15 times 1 over 15, we end up with 1. And the last property is distributive property, And we do go over distributive property a little bit more detail later on in Math 9, but just to get a little, heads up of how it works. So on the left side, we have 3 times and then 5 plus 8 in the brackets. That's the same thing as 3 multiplied by 5 plus 3 multiplied by 8. Okay, which gives us 15 plus 24, which gives us 39. The other way you could have done that is if you had the 3 multiplied by 5 plus 8, which is 13, which will still give us 39. 39 on the left side, it's still equal to 39 on the right side. This example here, we have 23 times 99. So using distributive property, what you can do is we know that 100 minus 1 is 99, and it's easier to multiply 23 times 100. So 23 times 100, we know that is 2300, and then 23 times 1 is 23. Then you can subtract those two to give us 2,277. All right, so let's just take a look at these examples here. So we have negative 2 over 3 times negative 3 over 2. So we know this is the reciprocal of negative 2 over 3. All right, so since we're multiplying negative 2 over 3 by its reciprocal, that means we are using our multiplicative inverse property. All right, so our answer here, it's going to be equal to 1. And I got that very easily because I used the property of multiplicative inverse. I'm just going to put MI for that. All right, here in this example, we have negative 9 plus positive 9. So from our properties here, we know that if we take additive inverse property, the answer will be 0. So we are ending up here with 0 divided by 1. Our answer will just be equal to 1. Okay, and the property I used here, this is 0 divided by 1. The answer is 0, not 1. And the property I used was the additive inverse property. I'm just going to call that AI. All right, so next we have 8 minus 3 minus 9. So here, that property we're using is associative property. I'll just call it AP. But the answer here, 8 minus 3 is 5. I'm just going to show it like this. So then we end up with 5 minus 9. Our answer is going to be negative 4. And we used associative property. So AP. All right, 45 times 101. This is the one where we can use distributive property. So we can take our 45 and we can multiply it by 100 plus 1, like that. All right, 45 times 100, that's easy. We know 40 times 100, that'll be 4,500. And then 45 times 1 is 45. So 4,500 plus 45, which gives us 4,545. All right, and so this was distributive property that I used. So I'll just put DP for distributive property. And the last one, 73 times 45 minus 45. Well, 45 minus 45, that's 0. 73 times 0. Anything times 0 is 0, so that's just equal to 0. All right, and the property we used here, we can say we used the 0 property, as well as the associative property because we have those brackets there. So I'm just going to put here 0 property and associative property.